When people talk about Microsoft Fabric, you might have heard terms like workspaces, capacities, domains, items, and tenants. And then there is OneLake and these different data stores like lakehouses and warehouses. But maybe you are not fully sure how all of these connect and tie together and what they really mean. Don't worry, this video is here to help. We are going to break down the structure and terminology of Microsoft Fabric in simple and easily understandable way. Stay tuned for more. Welcome to the video. My name is Alexia and I'm a data architect and Microsoft Data Platform MVP. And on this channel I cover Microsoft Fabric related topics. In this video we are going to learn about the structure and basic concepts of Microsoft Fabric and how those different concepts like capacities, workspaces and items relate to each other. Also we are going to learn about OneLake, that is underlying data store behind Fabric. But now let's get started. Let's start by covering the core terminology and structure of Fabric. If you're working in a Microsoft Fabric environment, you will hear terms like tenant, capacity, workspace, domain, and subdomain, etc. thrown around. And if you're not familiar what those terms mean in Fabric context, those conversations can feel quite confusing. But now let's break down this Fabric rabbit hole so that those terms don't feel so scary anymore. Let's start this rabbit hole from Microsoft Entra Tenant. Basically, if you're using any of Microsoft Cloud services, you have to have a tenant. You can think of tenant as a dedicated playground that Microsoft has given for your organizations to build your services into. Also, with the tenant, you get some identity and access management for your organization. For example, if the company you are working for is using Microsoft Cloud services like Microsoft 365 services that cover very commonly used services like Outlook, Word, Excel, and Teams, you know that you can use organizational account, meaning basically your email, to log into all of those services. And that is made possible by having a tenant on the background. You could say that tenant is like a backbone for all of your Microsoft services. So basically, very briefly summarizing, tenant is a control center for managing users and security across Microsoft Cloud services. There is also a possibility that organizations could have multiple tenants, but let's not complicate this example with those. And for now, it is good to know that that is just possible. And like Teams and other Microsoft Cloud services, Fabric is also one of the cloud services provided by Microsoft, and it is deployed/enabled to be used for your organizational tenant like those other services. And at this point, I hope you already know that Microsoft Fabric is a data platform service provided by Microsoft. So this means that there is only one Microsoft Fabric per one organization if single tenant is being used. That is the most typical scenario. Now the question could be, does it become very messy if the entire organization is using just one data platform, and how you could have some separation per business unit or per person? Compared to other Microsoft services like Teams, it would be very problematic if the entire organization would only have one Teams channel and everybody would be having discussions there. Also, with Fabric, things can be separated, and the way to separate things in Fabric is to use workspaces. By default, every Fabric user gets their own workspaces called My Workspace that can be used to build stuff inside Microsoft Fabric. Also, other workspaces can be created based on needs. For example, your organization might want to separate financial stuff from supply chain stuff by dividing things into their own workspaces. Then these workspaces will act as a containers for different Fabric items that those specific business areas are using to build their specific data solutions that fulfill their business needs. And those data solutions on those workspaces require compute in order to work, and thus those workspaces consume Fabric capacity. And this is the next term that we are going to cover in this rabbit hole. Basically, Fabric capacity is the thing that powers up Fabric, and the size of the capacity determines how much compute power you have under the hood for your Fabric resources to use. And of course, bigger is better, but in this case, more expensive as well. And the capacity happens to be the main cost driver, and the majority of the costs associated with using Fabric come from running the capacity or capacities. If we come back to the workspaces, this means that every workspace has to be attached to capacity in order for you to be able to do anything within that workspace, because without compute, nothing happens. Also, in many instances, it is smart to have multiple capacities and not just rely on one. There are multiple reasons why this is the case, but for example, organizations could want to separate different countries to their own capacities due to multiple reasons like data regulations or cost tracking, to name a few reasons. Also, in many cases, it could be a good practice to separate production workloads from development and testing workloads to different capacities, so that development and testing doesn't accidentally eat up your whole production capacities and cause issues in your production environment and with some business critical reporting and data solutions. Also, we have a possibility to group workspaces by using domains. This adds one more governance layer on top of the workspaces and makes it possible for different business areas to manage data according specific regulations, restrictions, and needs. Then in Fabric, we also have a possibility to add subdomains inside domains that allows fine-tuning this grouping even more. And now we get to the juiciest part of the platform where the action happens. Inside every workspace, we can create Fabric items like data pipelines, data flows, notebooks, semantic models, and Power BI dashboards and reports. And also we can create data stores like lakehouses and warehouses. Every item in Fabric has to be created to some workspace, and these items are the building blocks of this platform, and they provide different types of capabilities like for storing the data or transforming it. However, the rabbit hole doesn't end here, because inside some of those items we can create objects. The most easiest example is the Fabric warehouse, since to that data store we can create objects like tables, views, and stored procedures. And these objects allow us to fine-tune our governance and access control to this very fine level. And now we have completed our entire picture here. And now somebody could be wondering that this looks quite complex, and what is the reason for all of these different layers here? Well, the simple answer is that since we only have one Fabric per organization, we want to have multiple layers that allow us to build and enforce governance and access management. Let's use another way of visualizing Fabric structure to really nail and understand it. In this diagram, we can see all of those same elements excluding domains and subdomains that we saw on the previous slide. In the top, we have the tenant level, and from that perspective, Microsoft Fabric is just another service in your organizational tenant, like for example Teams and SharePoint are. Then we have the capacity level that powers up Fabric platform under the hood, and we can have multiple capacities for our Microsoft Fabric platform. Then we have the workspace level, and we can attach multiple workspaces to a single capacity, which means that then those workspaces share the same compute resources of the capacity. This also means that if one workspace eats all the compute resources of the capacity, then nothing will work in those other workspaces tied to that same capacity, since there is no compute power left for them. That's why you need to be mindful about your capacity strategy and how you divide things to different capacities. After that, we have the item level, where we have all our different Fabric items that can be created to the workspaces, like those different data stores like lakehouses and warehouses. Also, we can create items that do not store data but move and consume and transform it, like data pipelines or reporting items that display data like Power BI reports and dashboards. Then we have the object, row, and column level layer, which means the layer to which the actual data is stored. Here we have our tables and files that are brought to Fabric or created there as part of some data transformation process. This is also the layer where we have the OneLake, that is the default data store for all data in Fabric. And next, let's talk more about OneLake and what it is, and what is the relationship between those different Fabric data stores like warehouses and lakehouses to OneLake. Let's start with the basics. OneLake is this unified data lake for entire organization. And like the name implies, there is only one OneLake per Fabric. If you're familiar with Azure Data Lake Storage, you can think about the OneLake as SaaS or software as a service version of Azure Data Lake. Basically, OneLake is built on top of the same technology, and Microsoft has just made it easier for organizations to use without needing to manage Azure infrastructure related to managing data lake there. And like with Azure Data Lake, we can store files and tables to OneLake. And the default data format for tables is the Delta Parquet format. That is a very powerful open source data format capable of handling huge amounts of data. This same data format is being used, for example, in Databricks as default data format. That is another huge player on the data platform scene and can be found on Microsoft Azure. And in Fabric context, OneLake data storage is also generating costs along with the capacity consumption, but usually these costs are significantly smaller compared to capacity costs. All the things we have mentioned until this point about OneLake could be more or less achieved by using Azure Data Lake, but OneLake has some aces in its sleeves, and one of the most notable and interesting of those is the possibility to create shortcuts. And what are these shortcuts, one might ask? Well, these shortcuts are a way to show data in OneLake that is actually sitting in some other place physically. In other words, this is a way to virtualize data using OneLake. This feature is very powerful in many ways, but one of the main advantages of this method is to eliminate data duplication. That tends to happen when organizations move their data from one place to another. Also, the big vision behind this shortcut is to make OneLake a portal to all the data that the organizations have. Currently, Fabric has already shortcut possibilities to many different external systems, and to name a few common examples, you could now create shortcut to AWS S3 bucket, Microsoft Dataverse, or to Azure Data Lake. Also, these shortcuts can be used internally in Fabric to shortcut data from one workspace to another, which means that we don't need to replicate data within OneLake when using it in different workspaces. Then we have another convenient way of bringing data to OneLake without building data pipelines, and this way is called mirroring. The basic concept of mirroring is to copy data near real time from a database into OneLake. Mirrored databases can be outside of Fabric, like for example Azure or on-prem SQL Server databases, or one of the Fabric's internal databases like KQL database or SQL database. Typically, this mirroring happens in incremental fashion so that changes that are happening in the source database are then reflected in the mirrored database in Fabric. This mirrored data is stored in a Delta Parquet format to OneLake, and it is ready to be consumed for analytics or any other use cases. There are a few different types of mirroring methods like database mirroring that we are discussing here, then there is metadata mirroring and open mirroring, but those are out of scope for this video. Okay, cool. Now we have some data in our OneLake, and now we would need to access that data. How do we do that? The answer is that on top of the OneLake, we have a serverless compute layer that is powered by a Fabric capacity that provides the compute for Fabric. And like in many modern data platforms, the compute and the storage have been separated from each other, and so is the case with Fabric. This compute layer provides many different interfaces for accessing data in OneLake, and we have interfaces like Spark, t-sql, Power BI interfaces, KQL, and many others that can be used to interact with the data in OneLake. Then we have to have some data consumption activities, meaning items and tools that use this compute layer to access the data stored in OneLake. There could be many different ways the compute layer is used for data consumption purposes, but the most typical way in Fabric context is use one of the items/tools that Fabric offers, like data pipelines, data flows, or Power BI items to access and use the data. Of course, the data consumption could happen from a third-party service or application. And like discussed previously, OneLake is built on top of Azure Data Lake and has those same basic interfaces like ABFSS and Spark that can be used to access the data in similar way you could access Azure Data Lake. And now some of you could be wondering, why do we need OneLake since we have those data stores in Fabric like Lakehouse and Warehouse, and we can just store our data there? Well, when you're storing data to those data stores, you are actually storing your data to OneLake, and those data stores are just the primary way of accessing the data in OneLake. And even though data formats in those data stores might look different, they use Delta Parquet files in the background to store their data. Also, to Lakehouse you can store some raw files as well, but the tables in Lakehouse are also using Delta Parquet as their format. Next, we are going to open up Fabric and do a quick walkthrough there to understand these concepts via Fabric UI. Before we open Fabric, I would like you to know that I spent a ton of my free time creating these videos for you, and that's why I would like you to hit that like button and subscribe to the channel for more Fabric content. This doesn't cost you anything, and I would highly appreciate that. Also, you can join my YouTube channel as a member and get some exclusive perks like early access to many of my videos, members-only videos, priority replying comments, and much more. And as a cherry on top, the theory slides in this video are available for channel members to download. And another way of showing support is to buy me a cup of coffee by clicking the Buy Me a Coffee link in the description. But now, let's go to Fabric. Now we have Fabric open here, and here we can see the Fabric UI. If you're coming from Power BI background, this UI should feel very familiar to you, because basically Fabric is just an extension of the Power BI platform. And actually from this bottom left corner we can actually change to the Power BI view. So here we have the Power BI view where we would be able to also create those Fabric items, but this view is more tailored towards Power BI developers. So let's switch back to the Fabric view. From this sidebar we can see that I have my workspace open. Let's open up that. Basically, my workspace is this default workspace that is created for every Fabric user. To my workspace, you can create your own Fabric items and test things around, but be mindful that my workspace is closely associated to your account, and if your account is deleted, then the my workspace will be gone also. So a better practice is to create another workspace where you would be building your stuff. So we can click here new workspace, and then we have to give a name to this workspace. I'm going to create this workspace for this DP600 tutorial, since this video is part of the DP600 series. Then we could give a description for this workspace, and we could also assign to this workspace to some domain or subdomain if we would want to have more governance control over this workspace. And then under this advanced section, we have to select the licensing mode for this workspace. I'm actually going to use this Fabric capacity. We also have these other options here, but the Fabric capacity is the most typical way to go around. And this is basically the compute that will power up the workspace. And we can see one capacity in this list here. And basically I have this capacity running in Azure, because the Azure is the place where you would create these Fabric capacities that then power up your workspaces. And in this view, we can also see some information about this capacity, like that the location is in North Europe, and then we can see one of the most important information, that is the capacity size. We can see that this is a F4 sized capacity, and on this change size page, we can actually scale up or down this capacity. But we can see that there are a lot of costs associated if we would start to scale this capacity up. And also these prices that we can see here are this kind of a list prices or pay-as-you-go prices. But if you would buy this capacity reservation from Microsoft, you would be able to get these prices down. But for my needs, this F4 should be a sufficient capacity for me to build these things that I'm going to build in this series. Also, it is possible to pause the capacity by clicking this pause button here to pause it so that it won't generate costs. But in that case, nothing in those workspaces tied to that capacity will work, because basically the compute is down, so you are not able to execute anything. Now let's go back to Fabric and let's create this workspace. Let's click Create. Now we have this empty workspace here, and to this workspace now we would be able to create some Fabric items. We can click this new item button here. And here we have the list of all the items that could be created to this workspace. First we have these items for getting the data, like for example copy jobs or data flows, or then we have data pipelines or notebooks. Then we have some items for storing the data. Here we have our data stores like lakehouses, warehouses, and event houses. Then we have some data preparation tools, and here we have some of the same tools that we had in the previous sections, like notebooks, pipelines, data flows, event streams, etc. Then we have some items for analyzing and training the data and for tracking the data. Then we have these items for visualizing the data, for example like Power BI reports and dashboards. And then we have some developed data items and some other items here as well. But now I would like to create the first data store to this workspace. And I'm actually going to create lakehouse first. And then we have to give a name to our lakehouse, and I'm going to add this suffix SE. That is going to mean that this lakehouse is schema enabled. So I'm going to use this lakehouse as a schema enabled so that we have this database type of schemas in this lakehouse. Let's hit create, and this will create this data store to this workspace. And now this lakehouse has been created, and we can see that this lakehouse has two folders/sections. We have one folder/section for tables, and then we have one for files. Basically, like we covered in the theory section, lakehouse is a data store that is able to store raw files and also some tables. To this file section, we would be able to upload any kind of data we want. For example, we could upload here CSV files or JSON files, or we could upload some audio files or video SQL files. Basically, the file type doesn't really matter. But to this table section, we then can create some delta parquet tables. So we have some delta tables that look like very traditional database tables, but they are using delta parquet format on the background. And it doesn't really matter if we are storing tables or files to this lakehouse, all of that data is stored to OneLake under the hood. Like we covered in the theory section, lakehouse is just one of the interfaces for accessing data stored in OneLake. So basically, this lakehouse is just metadata that is pointing to files and folders in OneLake under the hood. So in that sense, creating these lakehouses to Fabric is not the same thing like creating SQL databases or even storage accounts to Fabric, because these are basically just metadata pointing to OneLake. And now I would like to create another data store to this same workspace. So let's go back to the workspace, and this time let's create a warehouse to this workspace. So let's select warehouse, and then we're going to name that warehouse, and then we're going to hit create. And now we are creating another data store to this workspace, and this data store is a warehouse, and this looks like a traditional database. So we have these traditional database schemas like DBO and information schema and system schema here. But this data store is also storing its data to OneLake under the hood and in delta parquet format. But the interface accessing that data and using that data is a bit different, since now we are using t-sql as the main way of interacting and using that data. Now, to this same workspace, we would be able to create more Fabric items like data pipelines, data flows, or something similar that would actually bring in data to these data stores. And by the way, if you're using this video to prepare for the Microsoft Fabric DP600 certification exam, remember to check out certiace.com that offers free custom-made practice questions for DP600 exam. So after watching this video, go check out certiace.com. And that was all that I wanted to cover in this video. I hope you now have a better understanding of the core concepts of Fabric, and if you would like to continue your learning journey, check out the next video in this series. But now I thank you for watching and see you in that video.